Welcome to our channel Sankalp Study Success. In this video, we are going to learn about deterministic pushdown automata. Here, in the previous videos, if you see, we have learned what is pushdown automata and how to write the instantaneous description. So here, in this video, we are going to learn what is the deterministic pushdown automaton. In the deterministic pushdown automaton, how are we going to solve the problems is also we are going to see here, and this is the most very important topic from the third unit, where you can get the long answer from this unit from deterministic pushdown automaton. So here we'll see first of all what is a deterministic pushdown automaton. So let me write deterministic pushdown automaton as DPDA, right? So deterministic pushdown automaton is nothing but if all the derivations in the pushdown automaton has a single move, that means it should have a single move. That means what? That means it should have a unique transition. So, which is nothing but it should have a unique transition. So, if you carefully observe, in the pushdown automaton, if you are moving from one state to another state by applying any input symbol, then it should have a unique transition but not several transitions. If you are having a unique transition, then you will call it as deterministic pushdown automaton. అంటే మనం ఒక స్టేట్ నుంచి ఇంకొక స్టేట్కి వెళ్ళేటప్పుడు ఏదైనా ఒక ఇన్పుట్ సింబల్ అప్లై చేస్తే మనకి ఖచ్చితంగా ఓన్లీ that single move మాత్రమే ఉండాలి, అంటే వేరే వే అనేది ఉండకూడదు. సో that means you should have a unique transition. So if you see some of the examples, then you will come to know, you will have much more clarity on deterministic pushdown automaton. So now let us go into the first problem. Design a pushdown automaton for accepting the language L is equals to a to the power of n and b to the power of n. So given language is a power n and b power n, where n is greater than or equals to 1. That means our language which is generated will be a power n, b power n is nothing but if you substitute 1 in place of n, then you will get ab. If you substitute 2 in place of n, then you will get a square, b square, and so on, like this, a cube and b cube and so on. That means the language which is generated is having equal number of a's are followed by equal number of b's. So equal number of a's are followed by equal number of b's. Then here, how do we going to construct the pushdown automaton? There is we need to have the transition function, right? That means the moves. So moves are nothing but here the transition functions, or from one state to another state, the instantaneous descriptions we need to write. So you cannot remember the instantaneous descriptions for each and every language. That means for each and every string or for each and every context free language, you cannot remember those many instantaneous descriptions. So the thing is, you can take any one of the input string from this language. So first let me consider a square and b square, then transition function of q naught comma a square b square. That means nothing but aa bb. Let us write it in the form of aa and bb so that it will be clear for us. aa and bb comma z naught, because we are going to start our pushdown automaton with our initial state q naught, and the top of the stack will be z naught. So I'm considering a square b square. So if you see, how are we going to construct the pushdown automaton? We need to have a logic, correct? So for this, for equal number of a's, we are having equal number of b's. So we have learnt that pushdown automaton can be accepted by the final state, or it can be accepted by the empty stack. So if you can take it as for empty stack aa and bb, that means what? Here for each and every a, there is one more each and every b, correct? So let me take it as for every a, we are going to push an element into the stack, and for every b, we are going to pop an element into the stack. Then what happens? There are equal number of b's and equal number of a's. So So you will push equal number of elements into the stack and you will pop equal number of elements from the stack. So you will be remained with the empty stack, right? So at last, if you are remained with the empty stack, then you can say that the string is valid. If it is not, if you are not reaching to the empty stack, then you can say that the string is invalid, correct? This is the logic which we are going to follow for this question, because there are equal number of A's and equal number of B's. Now, our instantaneous description will become Q0, comma A, our instantaneous description will become, let us write the moves in the right hand side. Moves are, we are applying transition function of Q0, A and Z0. Let us go to the same state Q0 and we are pushing an element into stack, right? That is AZ0. So our move will become Q0, comma ABB, because we are left we have processed first A and then we are left with AZ0. Now we are in the Q0, A and A. There is no move for Q0, A and A. Let me write it here, Q0, A and A. We need to write the move, and there is one more A which we are going to process. That means we are going to push on another element A, that is Q0, comma B, and A. Right? Because here from Q0 we are going to the same state and we are pushing another element A. Now, what are we going to do? Here, A is Z0 also, let us write it here. Now, there is a B here. You need to process B. From Q0, if you process B, let us go to another state Q1, because we are processing a different input symbol, right? So, let us go to another input symbol Q1 and you have left with another B, and what we have discussed just now, if there is a B, then you need to pop an element from the stack. So this element is popped. So AZ0 is remained. So here that means, let us write this move Q0, comma B, comma A. Then you will get it as Q1, comma A. That means, it is not Q1, comma A, right? Because we have just popped an element. So let us write it as Q1, comma epsilon. So that we will come to know that we need to pop an element in this case. So we have popped it. Now let us take the next one is Q1, comma B, comma A. This is a different move now. So Q1, comma B, comma A. That means here there is a B. We are not going to the next state because already for the one B we have moved to the next state. So let us be in the same state and we need to pop an element because we got B here. So Q1, we have processed B, that means epsilon, and then you need to pop it, so it becomes Z0. So Q1, epsilon and Z0. So this is our last move because Q1, epsilon and Z0. Then in order to get the final state and also empty stack, we are going to the next state Q2, so that it will be also accepted by the final state and also accepted by the empty stack. So we are going to Q2 and epsilon, so that we will get the empty stack, right? So it becomes, Q1, comma epsilon, comma Z0 will become Q2, and this is the final state here. So in the push down automaton, we have reached to the final state and also empty stack. So we can say that this AABB is a valid string and we got these many number of moves here. So these are nothing but our instantaneous descriptions or our transition functions. So now we are going to draw the transition diagram for the given push down automaton. So how do we draw the transition diagram for the given push down automaton? Here, by considering these moves, there are Q0, Q1 and Q2, right? There are Q0, Q1 and Q2, only 3 states. So let me consider it as Q0, this as Q1 and this as Q2, where Q0 is the initial state and Q2 was the final state. So let us make initial state and final state. So from Q0, I'm going to Q0 only by applying A. Then it becomes, how we are going to write, we are going from Q0 to Q0 only by applying A, comma, our previous stack was Z0 and we have pushed AZ0. It became AZ0. So in this way, we are going to write the instantaneous description using transition diagram. So the next thing is Q naught AA. Again, we move to the Q naught only. So in the same step, we are going to write A, comma, top of the stack was A and then it became AA. Now we are going to take Q0 comma B comma A. That means we are going to Q1. So there is a move from Q0 to Q1 by applying B. Then our input by applying B, then it becomes A comma epsilon. That means A or epsilon, because the previous top of the stack was A and then it became epsilon. Then now we are in Q1 state. So Q1 comma B comma A will again go to Q1 only. So it is B. By applying B, the top of the stack becomes A to epsilon. So A or epsilon. Now from this Q1, we are going to Q2 by applying nothing. That means by applying epsilon, right? So there is a move from Q1 to Q2 by applying epsilon, and the top of the stack will become Z0 or epsilon. So this is nothing but the top of the stack. So this is the final state which we have reached to Q2. So this is our transition diagram for the given pushdown automaton. So in this way, we are going to solve this type of pushdown automatons. That means for any pushdown automaton, you are not going to remember those many number of transition functions, right? Those many number of instantaneous descriptions. So we have to take any valid string, then process it so that you will get the instantaneous descriptions or the moves from one state to other state, and then draw the transition diagram according to the states. Now let us go into one more question where we need to design a pushdown automaton for accepting the language 0 power n and 1 power 2n, where n is greater than or equal to 1 by empty stack. That means here you have to accept it by empty stack only. It is specified that it should be accepted by empty stack. If it is not specified, then it can be accepted by empty stack or the final state. That may be up to you. But if it is given that it should be accepted by empty stack only, but if it is given it should be accepted by the final state only, then you should solve in that manner only. So now here, if you observe, it is 0 power n and 1 to the power of 2n. That means any number of zeros are followed by even number of ones, correct? If you observe carefully, any number of zeros are followed by even number of ones. So that means 011 will be one string, 004 ones will be another, 000 or 4 zeros, 4 ones, and so on like this. So that means you will get any number of strings, but the condition is any number of zeros should be followed by even number of ones. So now, how are we going to push or pop the elements from the stack in order to end with the empty stack? So here, if you take for zeros, if you push into stack, that means it is a logic. For zeros, if you push in the stack, and for ones, if you change the state and no change in the stack, because for 0, see here, 0 power n and 1 power 2n. That means what? If you substitute 1, then you will get 1 0 and 2 ones. If you substitute 2, then you get 2 zeros and 4 ones, right? So that means for 1 0, you are getting 2 more ones. Here we are getting 4 zeros, means you will get 8 ones here, right? Sorry. So that means for 1 0, you are getting 2 ones. So if for 1 0 you are pushing an element into the stack, and for 1 1 you have to change the state but no change in the stack, and for the other one you need to pop an element from the stack, then it becomes balanced, right? For example, there is 011. This is a valid string, and for this string, for this 0 I am going to push into the stack. For 1 0 we are having 2 ones. So for this first one, what I am going to do is change in state, but no change in the stack. And for this last one more one, I am going to pop an element from the stack. Then what happens? Pushing one element, popping one element, and there is no change in the stack, so it becomes balanced, correct? So in this is the logic which we are going to follow for this question. So you need to think the logic, analyze the question, think the logic, and then solve the problem. So now let us take 0 0 4 ones, correct, because it is a bit lengthy. Q0 comma 0 0 4 ones along with the top of this stack, which is Z0. So this becomes, let us write the moves simultaneously at the right side. So here our move is transition function of Q0 comma 0 comma Z0. This will be equal to, see, for this 1 0 we are not going to change the state anyhow, so transition function of Q0, and we are remained with 0 and 4 ones, and also we are pushing an element into the stack for the zeros, right? So AZ0. So this becomes Q0 comma AZ. So this is our move. Now there is a move called Q0 transition function of Q0 of 0 comma A. Here for another 0 we are going to go to the same state and we are going to push an element into the stack, right? So it becomes AA. So Q0 comma 4 ones, then it is AA. Now what happens? For first one we are going to change the state. Here our transition function of Q0 comma 1 comma A. Here you are going to change the state, but there is no change in the stack. So it becomes Q1 comma A. So that means here it is transition function of Q0 comma 3 ones and there is no change in the stack. So AA will be as it is. Now this is not Q0, right? This is Q1 because there is a change in the state. So now the move is Q1 comma 1 comma A. For this move Q1 comma 1 comma A, for this another one, that means we have done with 1 1, and for the next one you need to go to the previous state and then you need to pop an element, right? So I'm going to the previous state Q0 and remained with the 2 ones and popping an element where you will be remained with AZ0 only. See, there is a Z0 here also. So if I'm popping one element, you are remained with AZ0. Now you have already Q0 1 and A. There is a move from Q0 1 and A. It is nothing but Q1 comma A. So it is nothing but Q1 and you are left with 1 1 and A. That is nothing but there is no change in the state, which is AZ0. Now you are having again Q1 comma 1 comma A. So the move is Q0 comma epsilon. So you are moving to Q0 comma epsilon because there is no more strings here. Epsilon is nothing but removing an element from the stack, so you are remained with Z0. So now let us write this move Q0 comma epsilon comma Z0. Then you can go to the another state or you can be in the same state only. Then you are remained with Q0 comma epsilon, which is equals to, here it is not equals to, right? It says Q0 comma epsilon. So here you are remained with the empty stack. So that's the reason here it is given that you need to remain with the empty stack. So for that reason we are not going to take the final state because it should be ended up with the empty stack. So here it is nothing but Q0 comma epsilon. So we have ended up with the empty stack. So these are the moves for the push down automaton. So let me construct the push down automaton. That means let us draw the transition diagram where it consists of only two states, right? Q0 and Q1. That's it. There is nothing, no more states here. So Q0, which is the initial state, and Q1. There is no final state here, right? So from Q0, if you apply 0, then it moves to Q0. If you apply 0, then it moves to Q0 and there is a change in the stack, which is Z0 to AZ0. So Z0 or AZ0. Then coming to the next move, from Q0, if you apply 0, then again it is going to same state Q0, but there is a change in the state, which is A comma AA. So this becomes 0 comma A of AA. Then here, coming to the next step, where we are applying one as the input to Q0. So if you apply 1, then it is moving to another state Q1 So from Q0 to Q1, if you apply 1, there is a change in the state from A, change in stack from A to A, because we are moving from Q0 to Q1. And the next move is, if you are moving from Q1 and if you are applying 1 to Q1, then it is moving to the previous state Q0. So here from 1 we are going to Q0 by applying input symbol 1. So our stack will going to change from A to epsilon, because we are popping an element, right? So from A to epsilon. And here from Q0 we are again going to Q0 only, but by applying the stack symbol as Z0, then we are going to again pop that Z0, because we need to end it up with empty stack. So from Q0 we are going to Q0 by applying an input called epsilon. So epsilon comma Z0, and you are ending up with empty stack. So this is our transition diagram for the given push down automaton. In this way we have to draw the transition diagram for the push down automaton by considering the instantaneous descriptions. So thank you for watching the video.